What's up, people? I'm back yet again on this series for redox reactions. Thus far, it's been a series that we've treated a few concepts. This is the second video in the series. And by the way, my name is David, and all we do here is to take the mystery out of chemistry so chemi can make history. So, without wasting time and without any further ado, let's go into what we have for today. We're treating the concept of oxidation numbers. So let's understand basically what an oxidation number is. Now, in chemistry, an oxidation number is also called an oxidation state. Oxidation number is also called an oxidation state. It is a number that is assigned to an atom in a chemical compound that shows how many electrons it has gained, lost, or shared during a chemical reaction. Now, remember, when we started this series, we started by saying a redox reaction is a reaction where both oxidation and reduction are taking place at the same time. And remember, we said oxidation is the loss of electrons and reduction is the gain of electrons. So now there is a way we can use to find out whether an atom gained electrons or lost electrons, and that is what an oxidation number is. It is a number that is assigned to an atom in a chemical compound that shows how many electrons it has gained, lost, or shared during a chemical reaction. Now, oxidation numbers help us a lot. And there are some things that it helps us to do. First of all, it helps us to track electron transfer in redox reactions. It helps us to track electron transfer in redox reactions. And it also helps us to determine or find out which element is oxidized and which one is reduced. It helps us to determine which element is oxidized and which one is reduced. Now, think of it like a score. Okay, think of an oxidation number like a score, which tells us how charged an atom is, whether it's behaving like it has gained or lost electrons. Now, for instance, if somebody wrote an exam and he scored, let's say, 20 over 100, and another person wrote an exam and he scored 70 over 100, and then I ask you who got an A and who got an F in the course. Of course, you know that the person who got an A is the person who has 70 over 100, and the person who got an F is the person that had 20 over 100. Why? Because of the scores that they have. So oxidation number works much like that. It is more like a score that is given to an atom in a chemical compound that tells us whether it is losing electrons or it is gaining electrons. Now, this brings us to the concept of knowing how to assign oxidation numbers. How do we know what the oxidation number of an element is? There are rules to it, okay? Now, there are rules to give oxidation numbers to atoms or elements, and here they are step by step. First of all, the oxidation number of an atom in its pure element is equal to 0. Is equal to 0. For example, oxygen, hydrogen, sodium, and chlorine all have oxidation numbers that is equal to 0. Any element they give to you, whether it is oxygen, magnesium, whether it is calcium, as far as they are in their pure state, it is equal to 0. That is the rule number 1. Now, what is the next rule for assigning oxidation numbers? The oxidation number of a monoatomic ion is equal to its charge. Now, don't get confused. This word monoatomic simply means having just one atom. If you notice at this point, monoatomic deals with two words, mono and atomic. Mono here simply means one, and then atomic stands for the word atom. So whenever you have an ion and it is monoatomic, that ion has its oxidation number to be equal to its charge. Now, what do we mean? For example, look at this. We have sodium ion. Now, I want you to know that sodium ion is not equal to sodium atom, because here there is a plus. Why here there is no plus? So this plus is simply telling us that this is an ion. Now, what do we mean here? This plus here, if you look at it closely, there is no number attached to it. It is just a plus. That tells us that the charge here is +1. Whenever you see any sign of an element in chemistry, let's say maybe chlorine, sodium, or anything, and then you see a sign on top of it, maybe there is a minus, what is simply telling you that the oxidation number of that ion is equal to the charge that is standing on here. So now look at this case now, chlorine that I just wrote down. Chlorine has a charge that is minus or -1. So here now its oxidation number will simply be -1. The same thing, okay, I've just done that now. The same thing for magnesium. You can see the charge here is 2 plus. So therefore, its oxidation number will be +2. That is the rule. The oxidation number of a monoatomic ion is equal to its charge. I hope I'm making sense thus far. I hope I'm making sense thus far. Next rule is that oxygen is usually -2 in compounds. Oxygen is usually -2 in compounds. For example, let's say you have water, H2O. What is simply telling you is that the oxidation number of oxygen in this compound is minus oxygen. But there are some exceptions, okay? In compounds like peroxides, we have hydrogen peroxide. Oxygen is usually -1. But more often than not, when oxygen is in a compound, when oxygen is in a compound, we simply give it the oxidation number of -2. I hope you are following thus far. If this video is being educative to you, I'd like you to like this video, subscribe to my YouTube channel, and follow for more. Next rule is that hydrogen is usually +1 in compounds. Hydrogen is usually +1 in compounds. Hydrogen is usually +1 in compounds. In metal hydrides like sodium hydride, hydrogen is -1. But more often than not, whenever you find hydrogen in any compound, it is usually +1. For example, in the previous slide, I said H2O. Whenever you find hydrogen in a compound, usually the oxidation number is +1. Now, I hope you are noting down all these rules because we're going to use it for some practice questions where we'll find the oxidation numbers of atoms and elements. Next rule is that the sum of oxidation numbers in a compound is 0. The sum of oxidation numbers in a compound is 0. Now, we talked about hydrogen and then we talked about oxygen. Now, look at this rule. It says the sum of oxidation numbers. The sum of oxidation numbers in a compound is 0. What do we mean? We have H2O, for instance. And remember we said that hydrogen usually has the oxidation number of +1, while oxygen has the oxidation number of -2. Let's prove this law. Let's see if we add everything here, will it give us 0? So we have hydrogen, which is +1. How many atoms of hydrogen do we have? We have 2 atoms of hydrogen. So therefore, that gives us multiplied by 2 and then plus. Oxygen is usually -2. So we have -2. Let's add everything together and see what we'll get. This is +1 and then times 2. +1 times 2 gives us 2. This is plus over here and this is a minus over here. If we open the bracket, it becomes 2 minus 2. 2 minus 2 gives us 0. So we have proved that law that says the sum of oxidation numbers in a compound is equal to 0. I hope you are following. Next rule says the sum of oxidation numbers in a polyatomic ion equals the ion's charge. The sum of oxidation numbers in a polyatomic ion equals the ion's charge. What do we mean? So in this case now we have a compound, sulfur and oxygen making up a compound, SO4. And then we have 2 minus. What this is telling us that the sum of oxidation numbers in this case, since it is a polyatomic ion. Now, the word polyatomic is a combination of two words, poly and atomic. Poly here simply means more than one or plenty, and atomic stands for the word atom. So whenever you have a polyatomic ion, the sum of all the oxidation numbers here must be equal to the charge. What is the charge here? 2 minus. So when you add all the oxidation numbers in this compound, it must give you minus 2. That is the next law or the next rule of assigning oxidation numbers. The next rule here The next rule here says alkali metals or group 1 elements always have plus 1. And here are some examples: sodium, potassium, and lithium. Their oxidation numbers are always plus 1 in a compound. The next rule says alkaline earth metals. Alkaline earth metals, which are group 2 metals, always have plus 2. And the examples we have here: magnesium and calcium. I hope you're following thus far. I hope you're following thus far. Fluorine always has minus 1 in compounds. Fluorine always has minus 1 in compounds. We're going to be applying all these rules as we seek to solve some examples before we end this video. Other halogens, usually chlorine. Other halogens, usually chlorine, bromine, and iodine, usually have minus 1, unless they are combined with oxygen or more electronegative elements. Other halogens usually have minus 1. Now, here are some practice problems, and let's deal with them together. The first question says, what is the oxidation number of chlorine in NaCl? Now, if you remember, alkali metals always have their oxidation numbers to be plus 1. And we have sodium here, which is an alkali metal. And then remember, another law for assigning oxidation numbers always says the sum of oxidation numbers, the sum of oxidation numbers in a compound is equal to 0. So in this case now, we have the oxidation number for sodium, which is plus 1, and then plus chlorine. Now, since we don't know what the oxidation number is, let's just name it X. So plus 1 plus X gives us 0, since the sum of oxidation numbers in a compound is equal to 0. So now we want to find X. So what do? We simply isolate X by taking 1 to the other side. If we do that, X now becomes equal to minus 1. So the oxidation number of chlorine in this compound is minus 1. I hope you saw how I did it. Let's move on to the next example. What is the oxidation number of S or sulfur in H2SO4? So let's go ahead and solve it. Now, we have hydrogen. Remember, the oxidation number of hydrogen in a compound is plus 1. We have sulfur. We don't know what the oxidation number of sulfur is, so let's name it X. And then we have oxygen. Remember that oxygen has the oxidation number of minus 2 in compounds. And all these elements, remember, the sum of the oxidation numbers in a compound is always equal to 0. So now that tells us that H2 plus S plus O4 must be equal to 0. Now, what is the oxidation number of hydrogen? Plus 1. How many atoms of hydrogen do we have? 2. So that becomes plus 1 times 2, then plus sulfur. Since we don't know what the oxidation number of sulfur is, we just name it X, then plus oxygen. The oxidation number of oxygen here is always minus 2 in compounds, so we have minus 2. How many atoms of oxygen do we have? We have 4. So minus 2 times 4. Everything now equals to 0. 1 times 2 here. 1 times 2 is 2 plus X plus minus 2 times 4 gives us minus 8. Everything equal to 0. 2 plus X If we open this bracket now, that becomes 2 plus x minus 8 equal to 0. Now, let's collect like terms. Let's collect like terms. We have x now minus 8 plus 2 equal to 0. Now, minus 8 plus 2, that gives us minus 6 equal to 0. So let's take this 6 to the other side. Therefore, x is equal to plus 6. So therefore, the oxidation number of sulfur in H2SO4 is plus 6. I hope you saw how I did it, and I hope you're following thus far. I hope you saw how I did it, and I hope you're following. Now, next question. What is the oxidation number of manganese in KMnO4? Now, remember, we have an element here, K, and K stands for potassium, which is an alkali metal, and K has the oxidation number. K here has the oxidation number of +1 as an alkali metal. Mn, which stands for manganese, is what they asked us to find. So we don't know what it is. Let's name it X. And then oxygen has the oxidation number of -2. Remember, the sum of all oxidation numbers in a compound must be equal to 0. So let's go ahead and find it. So that gives us K plus Mn plus O4 equal to 0. What is K? K is +1. What is N? N. Mn is what we don't know, so we named it X. Plus oxygen is what? -2. How many atoms of oxygen do we have? We have 4, so that becomes times 4 equal to 0. So therefore, we have 1 plus X, then plus -2 times 4 gives us -8 equal to 0. 1 plus x, then -8. Let's go ahead and collect all the like terms. This becomes x minus 8, because when we open this bracket, it becomes -8, then plus 1 equal to 0. Therefore, x minus 7 is equal to 0. So let's take this 7 to the other side so we can find x. Therefore, x is equal to +7. So the oxidation number of manganese in this compound is +7. I hope you are following thus far. I hope you are following thus far. So now here are some practice questions that I want you to try out, okay? So find the oxidation numbers of these elements in these compounds. We have all this for you. I want you to go ahead and find it. So now we've dealt with the second concept in this series of balancing redox reaction. You can see we are taking it step by step. So next episode, we're going to be dealing with another basic concept in redox reaction. So until then, I'd like you to subscribe to this YouTube channel, like this video, turn on the notification bell icon, so when more like this come out, you'll be the first to know about it. I'm so excited that you stayed till the end of this. Thank you very much. Until next time, I come your way. My name is David, and all I do here is to take the mystery out of chemistry so chemi can make history. Thank you.